Hi, welcome to Exam Debug. I'm Chris McKenna, and today we're going to be having a look at some of the internal processing devices. So this is carrying on our unit of components that we started before. So to understand the different components, we need to kind of put them together a little bit. So we've covered certain devices already, and if you haven't, maybe you need to look back at the other videos before. So anyway, this is the system we have. So we have the input device, which then processes the input somehow. That can be stored either temporarily or in a more permanent backup. And then after processing, or after the input's processed, it can result in some kind of output to the user. And usually this output will return to the user, who will react on that output as some kind of input. So let's look at that in a more sort of concrete example then. So let's say you're playing a game. Your input is that you click the mouse in order to slash your sword at the enemy. So the process is the mouse click comes in. The process would be the computer working out what that particular thing does. So in this case, the mouse click. It will be going into the storage to retrieve what to do when the mouse clicked, and it will be returning the storage, will be getting the program back, and it will be processing what it has to do once it has received that mouse click. And then depending on the storage of what's already happening in the program and what it is supposed to be doing on a mouse click, it will give you some kind of output. Maybe causing damage to the enemy, or saying you missed, or something like this. And then, so that will be the output to the screen in this case. That feedback will then come back to the user, and the user will then make their next action. So obviously this is going to happen really, really fast. You know, your mouse click, you see the sword slashing, and you see the result straight away. But in between that, there's a process where the CPU is doing stuff, and it's accessing the memory, and perhaps it's storing results in the memory as well. So we've already covered this part here and this part here, and we've looked at some of the storage devices. So we're going to be focusing today on the processing, including how it's stored while processing. So as I'm sure you know, many people do, the brain of the computer is your processor, is your central processing unit, or CPU for short. So you're going to have to know that acronym. So the central processing unit is effectively just our brain. It does all the processing. Now, to be clear, like, a processor can actually only do a set of very simple instructions. It could be add, it could be compare, it could be simple things like this, and it can only do one single instruction at a time. So it can do a lot of those instructions in a very short space of time, but it's doing one short instruction after the other. So that might be load number from the memory, it might be add that number to another number, it might be compare to see if those numbers are equal, and from that we can get absolutely everything that the computer can do. It's actually quite amazing that from such small, tiny little operations, we can achieve the massive complexity of things that we can do on the computer nowadays. Okay, the second one is the random access memory, or RAM for short. So you'll often be asked to compare RAM and ROM and things like this. So let's have a look at what RAM is first, and then we'll move on to ROM. So random access memory is used to store the programs that are running when we are using the computer. Okay, so the programs that we're using, we usually load them into RAM, and then the computer, the CPU, can access them reasonably quickly. Okay, much faster than if we were to use, say, a hard drive to store our information that we were running on there. The way I like to think of this, and it helps for me, it might not help for you, but think of your RAM as like your desk. So when you go to study, you take the book that you're using, and you put it onto your school desk so that you can study. But you can't leave it on your school desk at the end of the day. If you do, the cleaner is going to wipe it away. It's going to be gone, perhaps. Yeah. So when you're at the end of the day, you have to put your stuff into your locker or a cabinet or school bag, and that's the equivalent of your hard drive. So the hard drive is maybe for your longer term storage. It's for keeping the stuff you're using when you're not there. However, your desk or the RAM is for your immediate quick access for the things you are using right now, or the things that the CPU, the applications are running right now. And the same goes here. So people then ask, well then why don't we just make everything RAM? Why don't we just have lots and lots and lots of RAM and don't have a hard drive? Well, the thing is, this is volatile memory. So volatile memory means when you turn off the power, it's gone forever. So we need something to keep it stored when the power is off. So when we leave the classroom, we can't leave all our books on the desk because that would cause problems. The other thing to think about here is a lot of people think they want their computer to go faster, so they should just keep buying more and more RAM. And that's also not good. So again, think about your desk. Now, you could make your desk bigger and bigger and bigger, and that would probably make things better to begin with. Having a bit more desk space is good. Yeah? Having more RAM is generally quite good. However, you start to reach a point where your desk gets so big that it becomes harder and harder to find what you're looking for. I mean, let's say you have a desk that's the length of your classroom, and you're having to walk up and down that desk to get to one book. You get that book, you read it, you need to get to another book, so you walk back to the other side of the classroom, you find the other book. Yeah, this starts to actually slow down the computer if you have too much or more RAM than your CPU can handle. So it's better to store things on your hard drive and load them into RAM as we need them. Okay, so that was RAM, or random access memory, which is volatile memory used by the computer to store running applications. Now, often you'll have to compare RAM to ROM. ROM stands for read-only memory. Again, something you're going to have to know. So, read-only memory is different from RAM in that it is non-volatile. This means that it cannot be changed. It means it's hard-coded onto the chip. Now, to make things very confusing, if you start looking at modern-day ROM, you'll see that it can be changed. However, for IGCSE, let's just keep it simple. In our minds, at least for now, ROM is unchangeable. It's coded onto the chip. And if you want, you can go and find out more about sort of modern ROM, like EEPROM and stuff, which has the ability to be changed. But for now, you only have to know that ROM doesn't change. It's read-only. Okay, so one of our most common examples, and the one that you will have to know for your test, is the BIOS, so B-I-O-S. Now this is a chip that comes on every motherboard. If you open up any computer, or any PC at least, you'll find the BIOS hard-coded onto the motherboard. Now the BIOS is very important. It has a special job, and that is to boot up the operating system of the computer. But before it can do that, it has to give some basic input, output, instructions on how to talk to certain peripherals or devices. In this case, on my computer, for example, the operating system is on the hard drive, so it has to know how to talk to a hard drive before it can start booting up the operating system. So this, when you press the on button, the program from BIOS automatically is taken and is started running in the CPU. And from that, we know how to talk to the hard drive, or whichever medium we're using, and we know the location of the operating system and the basics to boot things up and get things going. So that's BIOS, which is Basic Input Output System, which is an example of read-only memory, ROM. So at the most basic level, you have to know that RAM is volatile and ROM is non-volatile. That's a very common question that comes up. Volatile, non-volatile. Important vocabulary. Okay, so if you're looking for a little task to do, I find it's quite helpful here for my students to make a little flowchart about what happens when you turn on the computer and from then on. So you're looking at from when you press the start button, what happens? Remember, we're talking specifically about RAM, CPU, ROM, and the BIOS. So can you put those steps in order? Please don't try and copy this. This is just an example of a flow diagram. Caused some problems in class because students thought they had to fit things into this box. So this is just an example of what a flowchart is. Make your own flowchart with your own boxes in order to practice. Alright, so quite a quick one today. But here's what you need to know. You have to know that CPU stands for Central Processing Unit. And you have to know that that's the brain of the computer. You have to know that RAM stands for Random Access Memory, which is a volatile memory. That is, it's erased when the computer is turned off. And it's used for storing programs while we are running them. And then we have ROM, which is read-only memory, which is used in different places, but in our case it's used for storing, in this case, programs perhaps that we're going to use on the system. And it is non-volatile. Now you have to know the difference between volatile and non-volatile. That's quite an important one. So volatile, when the power is off, everything is lost from that memory. Non-volatile, when the power is off, the contents of the memory stay there. And you also have to know that BIOS stands for Basic Input Output System, and you'll have to know that it's responsible for booting up the operating system on the computer. Anyway, I hope that's been helpful to you, so please subscribe and give some feedback below, and we look forward to hearing from you.